further ado,
Yeah, without further ado, let's kick off Data Science Salon 2023. We're very lucky to have big round of applause for Suprit Kaur from Morgan Stanley talking about synthetic data. And Suprit, I'll hand it to you then.
yeah, so you can use either. Okay, I'll use. Okay, sure. Yeah, I'll use this. Okay. Good morning, everyone. I'm Supreet. I'm AI product manager at Morgan Stanley. Basically, I manage their flagship AI products, ensuring that we are getting enough users, we are making money, we are building strategies to get new customers onboarded, and the customer experience is flawless during this entire journey. So I closely work with our marketing partners, our data partners, our data scientists. A very collaborative, interesting, and upcoming role in the industry. Prior to this, I was a data science consultant, quote unquote, building machine learning models for the healthcare industry. So I know, though this is a finance conference, but you would still see a glimpse of healthcare because I've worked there, and I did want to share some of my experience. I also want to give a disclaimer. All views presented are mine and do not represent my employer. So let me start with the content. So the agenda is very straightforward. We are going to talk about an overview of synthetic data. What is synthetic data? Some of the advantages, some of the use cases from finance and healthcare, some practical techniques so that you can generate synthetic data if you would like to, how to validate the synthetic data challenges, and I would conclude by giving you some best practices that I've learned in my career. Sorry. Okay, now it works. Okay, so let's start with what is synthetic data. This clicker is not with me today. Just a second, guys. Oh, did I press two? Okay, let's go back. Okay. Okay, so what is synthetic data? As the name suggests, synthetic means it's obviously not real data, but it's something that can be generated with specialized skill set, specialized techniques, and a machine learning model to simplify it. And you will see as I talk about the techniques as to how you can generate it. And why is it important, right? And why do we need it in the regulated industries? Is there is a lot of private information in the healthcare sector when it comes to the customer data or the patient data. In finance sector, there is PII. We deal with SSNs and some proprietary customer information every day, and not everyone wants to use that. And if you are someone who's practicing responsible AI, you wouldn't like to see that information or use it in your model. So synthetic data gives you a way to artificially generate that information. So even if you had 10 SSNs now and you're using a synthetic data technique to generate it, basically the 20 SSNs that you get now don't really exist. So you can still see them and you are not violating any law per se. It allows the data scientists or researchers to conduct their research, to make new models. And even if you're a company that might be just starting out, you don't really have customer data, you don't have the money to buy customer data. But even if you have 20 or 30 good records, you can use that to generate more data and continue being a data-driven and an AI-driven organization. So some of the advantages, I'll reiterate, definitely retains privacy of customer data, which should be our primary goal when we are thinking about AI and machine learning. Our customers have trusted us with their data, so it's kind of our responsibility to protect it. The second is it provides edge cases, and I feel this is a very interesting benefit of synthetic data. If you see historically, when self-driving cars were being built, you don't really know how a driver is going to drive. And there are scenarios that don't really exist. But synthetic data gives you a way to generate those edge cases. Those edge cases don't exist in your historical data. And that is why even if some companies have historical data, they deliberately like to go with synthetic data so that they can simulate those scenarios. Another advantage is that it might be cost effective. Sometimes buying data and buying good labeled data might be expensive, so it's better to generate it with in-house talent. And the last one, as I also mentioned in my introduction, is if you want to augment the data, you want to increase the size of your data set because, let's say, you're trying to establish a deep learning model, synthetic data can come to your rescue in that case as well. Okay. Okay. So we are at the interesting part of the presentation, which is let's talk about some of the use cases. So historically, for finance industries, if you see fraud is always their primary goal. They want to reduce the fraud. They want to find the people who are disrupting their systems, and synthetic data can allow them to do it. The people who commit fraud are very smart, so you need a way to commit again and to be able to augment edge cases, and synthetic data allows you to do it. It also allows the traders, the quantitative analysts, to generate market scenarios so that they can expect and know what is going to happen, which might not exist in your historical data. Obviously, if COVID happens, I don't think synthetic data can help you there. But if something like this doesn't happen, synthetic data can come to your rescue again. And for financial advisors in the wealth management industry, it's again a very interesting use case where they can advise their high wealth customers better as to where they should invest, what they should do, what would the market look like in the upcoming months or years. And the last one being risk models is another important aspect in the finance industry. So without exposing any customer transaction data, by retaining all that information, finance analysts and data scientists can still build these models. Now let's talk about the healthcare use cases. So one of the primary goals, and even when I was doing consulting for some of the best healthcare companies, is how can we know what are the scenarios that lead for a person to have rare diseases or cancer? Now, if you know historically, they see the image of your mass and then they are able to say, okay, if the mass looks like XYZ, you are more prone to cancer or not. Now, here again, you need those edge cases, you need more data so that you are able to know all the shapes and forms the mass can exist, and then you can predict whether a person will have cancer or not. So synthetic data definitely helps there. And since all of these are rare diseases, there are like 200 or 300 patients that are suffering from it historically. So you won't even have historical data. So synthetic data, again, is of prime importance for the industries. And also for the industry that's building the drugs, they want to know, okay, how many patients will be suffering from this so that they can be better prepared. And in that case as well, synthetic data can help you to predict that. And another interesting scenario is for policymakers and for the people who basically design all these policies. Let's say when the COVID hit, they had to design something which they wouldn't have done in the past, or they had to dig, okay, how did the policies change when a pandemic hit? So situations like this, they are very rare, and for situations like this, you might just have like 10 or 15 records in your database. So synthetic data can help you that way as well, so that policymakers can be more prepared for scenarios that haven't come up but are more prone to exist in the future. Okay, now let's talk about some of the methods. So the first method is called GANs. It's a very popular way on how you can generate synthetic data. I'm going to talk about only two techniques today, just because of the time constraint, but there are multiple that are available out there. So basically, GANs are generative models, and we all know about generative AI now. GPT is one model, GANs is another. They don't get enough credit, but they are also very useful in generating synthetic data. Basically, the architecture of GANs is very simple. There's a generator and then there's a discriminator. As the name suggests, generator will basically generate the synthetic data. It will generate new data points, and discriminator will act as a classifier, where for every record generated, it will flag it as fake or real. And it keeps working, it keeps improving with the feedback that it gets from the discriminator network. And why it's called adversarial is because the way it's functioning. It's receiving the feedback from discriminator, it's improving, then it's again generating, and so on and so forth. So it's an iterative process with which you can generate synthetic data. And the second method is data augmentation. So basically, this is a technique, as the name suggests, to augment the data, to increase the data. But essentially, how you do it is for your tabular data, let's say, you can scale numerical features. You can scale them within a separate range, within a specific range, and you can discuss that range with your stakeholders or your fellow data scientists. You can add some random noise to numerical variables. You can do some imputation for your missing values. If you had your image data, you can basically rotate it in a different way. You can scale it in a different way. So all of these are ways to do data augmentation. And it can obviously help reduce overfitting. There are new variations that you're giving to the model, so your model is also becoming smarter with rich historical data. Okay. So these are the two techniques, but as I said, these are not exhaustive. There are a lot of techniques out there, but these are the two that are most popular, and there's a lot of open source that is available on these. Now, once you have the synthetic data, obviously validation is a crucial step in the machine learning life cycle. So the first method is very straightforward, which is now you have your real data, you have your synthetic data, train a model and compare the performance. And if the performance is exceptionally well with the synthetic data, maybe your synthetic data is not able to capture the properties of your real data. So it could be questionable. You should go back and see, okay, what's happening with the synthetic data. You can also compare the feature importance of your model that was created with your synthetic data and with the real data. But these two methods only work if you also have a good real data. Now, in cases where you don't really have real data and you're simply relying on synthetic data, you might want to compare it with other techniques. And by comparing with other techniques, I mean that use GANs, but then there are variations of GANs. Use them as well to generate synthetic data and compare each of the output which is produced by different methods of synthetic data. And the last one, which is very important, is seek help from your stakeholders, from the SMEs of the data. Once you generate them, you can always have an aggregated view. You can always talk to them, and you can take their true sense. There are people who have spent 20, 25 years in the industry. They might not be experts in AI, but they're definitely experts in the domain knowledge. So you can also count on them to get it validated. And I would conclude with best practices and disadvantages. So the first, obviously synthetic data is not perfect. There are some issues with that. The first one is there bias in synthetic data? It's a very important question that we have to answer as practitioners, and I have been doing some research on the side. I've been reading research papers, and this question still remains unanswered. They are still trying to solve it, but I don't have an answer yet. So you have to be careful once you generate the synthetic data. There could be a need to debias it by using debiasing techniques. Second is that, as I mentioned, if a rare event like COVID happens, synthetic data may struggle to replicate it. And that is one of the challenges as well. And another one is if your real data is too complex or has some unique interactions happening between different variables, synthetic data might not be a good option. I'm not saying you can completely discard it, but it might not be of the highest quality. And then the last one, which a lot of organizations suffer with, is lack of talent. Because to generate synthetic data, you need some kind of education in machine learning or data science or some kind of expertise. So that is another disadvantage. And now I'm going to conclude with best practices. So the first one is definitely to invest in good data quality. Even the basis of synthetic data is real data. So even if you have 10 good records, it's going to work. But you still need to fix your underlying data. You need to check for inaccuracies. You need to develop data quality frameworks just to ensure that whatever data you have is good. And again, good is very subjective, so it's up to standard. Let's put it that way. Um, it is also essential, as I said, to build data quality frameworks not only for your real data, but also for your synthetic data. When you're trying to validate your synthetic data, it's not a one off exercise that you do it once and you're good. As your real data evolves, as the customer preferences evolve, your synthetic data will also evolve. So you need a data pipeline to continuously monitor the performance. You might not be able to get the synthetic data right at once. It's an iterative process. You might have to tweak the parameters, see what you get for your company use case, and you might have to do it again multiple times till you get a good quality data. I hate the word good, but for the lack of better words, let's put it that way. Um, for the bias piece as well, you have to be careful, as I mentioned, that synthetic data still is, we don't really know if it deals with bias, what kind of inclusivity exists in the data. And especially since real data is biased these days, it is possible that your synthetic data might be biased as well. And the last one being, if you're thinking about synthetic data, you need to invest in good talent or to train your current employees so that they can generate good quality synthetic data. And that will be all for my presentation. Thank you so much for being patient listeners.